Welcome to Zaption Tour 9-2 Quadratic Functions, and today we're going to be talking about the axis of symmetry and the vertex more specifically. There's 5 boxes. So the essential understanding is this: in a quadratic function given as y equals ax squared plus bx plus c, the value of the b affects the position of the axis of symmetry. So the value of the b, so I'm talking about the value that's right there, has an effect on the axis of symmetry. So let's get into this right away. Okay, here's box number 1. I have 2 separate quadratic functions here. On the left-hand side, I have the quadratic function negative x squared plus 4x plus 3. And then on the right-hand side, I have 2x squared plus 4x. So the red equation represents the red graph of the parabola, right? The blue equation is the equation of the axis of symmetry. It is a line, and it always passes through the x coordinate of the vertex, and the vertex is labeled in green for you. Okay, so here's the first thing that I want to point out that you should notice. If I consider this one on the left-hand side here, the value of a is worth -1. The value of b is worth 4, and the value of c is worth 3. I pulled those from right here. -1, the 4, and then the 3. Okay? So here's the deal. If you take the value of b, which is 4, and you divide it by 2 times the value of a, which happens to be -1, and then take the opposite of that, notice you get this. You get -4 divided by -2, which gives you a value of 2. Now I know that was a lot, but this is the relationship between these things here. The value of 2 is very important because it shows up in 2 places. It shows up in the x-coordinate of the vertex, and it tells you the equation of the axis of symmetry. Okay, I'm going to do the second one over here. See if you can follow along. The value of a is worth 2, the value of b is worth 4, and the value of c is worth 0. So if I take the -b over 2a, if I take the relationship, this very special relationship of -b over 2a, I would get -4 divided by 2 times the value of a, which is 2, which gives me -4 divided by 4, which gives me -1. And notice the equation for the axis of symmetry is x equals -1, and notice that the x-coordinate of the vertex is also -1. That's a lot to notice, it's a lot to take in, but this is going somewhere, so just stay with me for a little bit longer. Okay, now let's focus on this number here, this number 7 and this number -2. How could I get the number 7 out of this whole problem? Well, here's what you do. If you take the value of the x-coordinate and plug it back into the equation, so -2 squared plus 4 times 2 plus 3, here's what you'd get. You'd get -4 plus 8 plus a 3. -4 plus 8 is 4, plus 3 is, oh my gosh, 7, and that's where the 7 comes from. Same thing over here. I'll move it over so you can see. If I take the x-coordinate of the vertex and plug it back in, I would have this: 2 times -1 squared plus 4 times -1. I'm just taking the x-coordinate and plugging it back into my x value. Look what you get. You get 2 times 1 minus 4. You get 2 minus 4. You get -2, and that's exactly where this one comes from. Okay, so there's a lot of information that's hidden inside the equations of quadratics, and that's what we're trying to pull out today. Okay, box number 2 is the big picture box here, the axis of symmetry and the vertex. So if you are given ax squared plus bx plus c, so if you're given any quadratic that looks like this, the axis of symmetry is always going to be the line x equals -b divided by 2a. It will always be this. And then this is related to the vertex because the vertex, remember, is a location. It is an x and a y location. So the x-coordinate of the vertex will always be this value, -b over 2a. It will always be that value for x. And then to get the y value in, you substitute that value back in, so we write it as f of negative b over 2a. And I'm going to do another example that shows you exactly how to do this. But this is the relationship that we need to understand. So given any quadratic, ax squared plus bx plus c, the axis of symmetry is always the equation x equals negative b over 2a. And the vertex is always located at that same point, negative b over 2a, and then re-evaluated back into the function to get your y coordinate out. Let's do an example next. Okay, box number 3, let's do an example start to finish. Write the equation for the axis of symmetry and the vertex, given the quadratic x squared plus 6x plus 7. So here's the first thing that we're going to do. We're going to find the value of a is a value of 1. Hopefully you see that. The value of b is a value of 6, and the value of c is a value of 7. So that's my first thing that I want to do. I want to get those 3 things down. Then, to find the axis of symmetry, we're going to take x is going to equal negative b divided by 2a. So that means that x is going to equal negative 6 divided by 2 times 1, which gives us a value of negative 6 divided by 2, which is negative 3. So therefore the equation x equals negative 3 is the axis of symmetry. Okay? And the vertex is located at the point here. So let's find the vertex now. In order to get the vertex, remember it's located at a point x comma y. I already know what the x value is. It's going to be negative 3. So the vertex is going to be located at negative 3 comma something. I need to figure out what the y value is. And the way I figure it out is I take the negative 3 and I substitute it back into the equation to find the y. So that's what I'm going to do. The y value is going to be located at negative 3 squared plus 6 times negative 3 plus 7. All right? So negative 3 all squared is a value of 9. So this is 9 minus 18 and then plus 7. 9 minus 18 is worth negative 9 plus 7, which is worth negative 2. So the vertex is located at negative 3, negative 2. Let's graph the equation in fluid math to make sure that everything is correct. So let's go ahead over here. So I've got x squared plus 6x plus 7. And we said that the axis of symmetry is the line x equals negative 3. And then we said the vertex was located at negative 3 comma negative 2. So let's put all this information onto a graph. So here's my vertex, or here's my parabola. Okay, so far so good. Let's put the line x equals negative 3, and that's the axis of symmetry that goes right through the vertex. And the vertex was located here, which is a minimum, which you can see down there is indeed the vertex located here at the minimum. So this does look absolutely correct. Okay, box number 4 is a U-try. I want you to write the equation for the axis of symmetry and tell me the location of the vertex. Hopefully you got the right answer, but if not, here is the process by which you obtain the right answer. The first step that you do is you write down the values of a, b, and c. So they are 1, 4, and negative 5. Next thing you do is find the axis of symmetry using the equation x equals negative b over 2a. Plug in your values and you should end up seeing that x is worth negative 2. Next you find the vertex, and we knew that the x coordinate was negative 2 based on what we found earlier. Then we take negative 2 and we substitute it back into our original equation, and we do the algebra to arrive at the answer of y is equal to negative 9. So therefore, when you put all this information together on the graph, you see that the vertex is down there at negative 2, negative 9. We see that the axis of symmetry is the line x equals negative 2, and then of course we have the graph to match. Okay, box number 5, we're going to graph a quadratic by hand using these 3 steps that I have outlined for you right now. So our goal is to graph the quadratic x squared minus 6x plus 4, and we're going to need a coordinate plane in order to do this. So make sure you draw yourself a coordinate plane. Step 1 is find the axis of symmetry and the vertex. Okay, so we're going to do the same steps. So I know the value of A is worth 1, the value of B is worth -6, and the value of C is worth 4. That's our first step. The axis of symmetry is located at the equation x equals -b over 2a. So therefore it's going to be x equals positive 6 divided by 2 times 1, which means that x is equal then to 3. My vertex is going to be located at the point 3 comma something. I find that point by plugging the 3 back into the equation. So if I take 3 squared minus 6 times 3 and then add 4, I get 9 minus 18 plus 4. That's -9 plus 4. That's equal to -5. So my vertex would be at 3, -5. Okay, then we got to find 2 other points that I could easily plug in. Okay, so let's just make a little table here. Okay, let's make an x, y table. If x is 0, this is a really easy point to plug in. If x is 0, I get 4 out of this thing. That's pretty straightforward. And then if x is 1, I would get 1 minus 6, which is -5, and -5 plus 4 is a -1. So now I've got 2 points, and then I just need to graph and reflect the 2 points that I have. Okay, so let's put the vertex located at 3, -5. So go over 3 and down 5, and then label it that is my vertex. Then draw in your axis of symmetry, which is the line x equals 3. So it is a vertical line at the line x equals 3 that goes right through the vertex, and label it as x equals 3. Then I have 2 points here. I have 0, 4. So take 0, 4 is that point right there. And then 1, -1. 1, -1 is that point right there. Now because I have an axis of symmetry here, I can reflect this point exactly 3 units over, 1, 2, 3, and this point exactly 3 units over, 2 units over. And then I have everything to draw my parabola. So I would just simply connect and draw arrows, and then connect and draw arrows. So step 1, find the axis of symmetry and vertex. Step 2, find 2 other points. Step 3, graph and reflect the points. And just to make sure that we did this right, x squared minus 6x plus 4. If we graph this one together, y equals x squared minus 6x plus 4. Oh, sorry, there we go. It's real mad at me here. There we go, and we graph it. It looks exactly like what we just came up with. There's the vertex at 3, -5. And this is the exact same picture that we just came up with as we graphed over here. Hope that makes a lot of sense to you guys.